We're going to talk about how we can facilitate communication from a fragment to the outside world. We're going to look at how we can facilitate fragments informing whether activities or other fragments that are contained within a fragment's parent activity that some state change or some event has occurred. To do that, let's take a look at an example application. What we have here is an activity that contains two fragments, different fragment types. So on top we have a fragment called image list fragment, and below we have a fragment called image display fragment. The difference should be relatively clear, but the idea is that our image list fragment contains, as you can see in its layout file, a recycler view. And that recycler view allows us to display a list of elements. The image display fragment contains only an image view. That image view is stored inside of a frame layout, whereas in our image list, the recycler view is the only element. It is in fact the root element. That's just a personal choice. You can have either or. The reason I can do this is because the recycler view is the only item in the layout, so I don't need to place it inside of a container. As you can see here, the image view is the only useful view. So I could have done the same thing. I could have made this image view the root element, but I decided to just have one of each. Inside the image display fragment, which I believe is the simplest, we see that this fragment is designed in the following manner. It has a factory method that is able to accept a resource ID for an image. So that is an image from our collection of drawables. And it will essentially set that as an argument, allowing us to extract that value later on in our onCreate and use that value as a property. So we store that in our current image ID property. Additionally, our application is also conscious of a previous state from another instance of the fragment. So if the fragment goes through any kind of recreation process and it had the value that is being displayed had been changed, we do not want to use the initial value. Rather, we want to use the changed value. So the fragment is always showing us the latest image that it was displaying, not necessarily the original image if it goes through a recreation process. Our onCreate view simply initializes the image view and returns the inflated layout. And onView created essentially just does something similar. We check to see if there was a previous instance of a value saved, and we call change image with current image ID if it was that there was a previous value. And this function, in either case, it exposes a function change image that accepts an image ID which is a resource ID, and it updates the image view with that ID. As you can see here, unsaved instance state is where we save information if the fragment is going to be restarted for any reason. We want to make sure that we have the previous image that was being displayed so we can display it again later here. The image list fragment, it's the same idea, except instead of having a simple image view, we have a simple recycler view. So this takes a few more elements, as you can imagine, but the general design is the same. We have a factory method that takes an int array, because now we're displaying a collection, but it is stored in as an argument, and then later on in onCreate stored as a property, just the same. We could also retrieve the prior state if we allowed for the changing of data, but since right now we're not allowing for that, then we're not looking at any saved instance state. So this is much simpler in that regard. On create view, inflates and returns a layout, and you'll recall that the fragment image list layout file, which is what this one is inflating, only contains a recycler view. So in onView created, where we receive as an argument the layout that was inflated for the view, we needn't try to find the recycler view inside of this view because this view is the recycler view. So all we need to do is cast it, and then I can properly set up that recycler view. So I give it a grid layout manager where, to provide context, I make a call to require context, and then I pass in the span count. Require context is a function that will give you a reference to the context object to which this fragment is attached, which for our purposes is always going to be an activity. This fragment could be attached directly to an activity, meaning it's directly embedded, or indirectly, meaning the fragment is inside of another fragment, which is inside of an activity. Regardless, this is going to give you a reference to the activity, but only if you are attached to the activity at the time you call it. So ensure that you only make this call, or simply using the context reference if you prefer, only use this when you know that you are in fact attached to your parent. So you should only try to access this property under certain circumstances, meaning only in certain callbacks and in certain places where there is a guarantee that you are in fact connected to an activity. Subsequently, I give my recycler view an adapter. That is an instance of custom recycler view where I pass in a collection of images that was received by the fragment. And I pass in a lambda for a callback, which is currently unimplemented. But let's just take a quick look at custom recycler adapter. And we see that it's a basic adapter that extends recycler view adapter. I've defined a view holder, and that view holder accepts an image view and assigns an on-click listener to that image view where it invokes the callback and passes up the item found at the current position to whomever provided the callback. So it will just invoke the callback function whenever an image view is clicked. Everything else is pretty standard. On create view holder instantiates an image view at runtime and places it inside of a view holder instance, and that's what it's returned. On bind view holder simply sets the resource of the image view to be the item at the current position, and get item count just returns the size of the collection. So that's what gives us this functionality. In my activity, we are not doing anything special at this point. Essentially, what we have here is a collection of resource IDs for images, my drawables. Fragment 1 is an instance of image list fragment, where I call the factory method and I pass in the list of images. Fragment 2 is an instance of image display fragment, so that's here, where I call the factory function or the factory method and I pass in just an image to start it off. So I make sure that I see something. And then I just attach both fragments to the activity, where the activity's layout has two containers: image fragment container 1, image fragment container 2. So this is where I place the image list. This is where I place the image display. So what is my ultimate goal? Well, what I would like to do is I would like to have any selection of an item in the image list fragment be reflected in the image display fragment. That is, picking an image should show me a larger view of that image in the second fragment. So what I need is some sort of communication channel from the image list fragment, whether directly or indirectly, to the image display fragment. And what we want to keep in mind is that whenever we design fragments, we want to make sure that they know as little about the outside world as is possible. we want to limit the amount of direct references and keep coupling to a minimum. In a case like this, where we want to have state changes that occur in one particular place or events that occur in one particular place be reflected in other places, we need to find a way to do that without these fragments knowing about each other. In order to do that, we're going to look at something called a view model. So a view model is just a container. It's a class that is able to hold objects and other types of data. But what makes a view model interesting is that when you instantiate a view model, you have to specify a view model store owner. The component to which a view model is scoped, once a view model is initialized against a particular component, that component being an activity or a fragment, it will remain in memory for as long as that component is in memory. Meaning, the view model will persist for the lifetime of the component, not the life cycle, meaning a single iteration from onCreate to onDestroy, but rather as long as the component, as long as the owner is in memory. So this can go through multiple, say, activity restarts, and the same view model instance and all the data it contains will always be there, accessible to all the components that need it. This view model can therefore be used to store and share information among all the child components and the component itself. So an activity and all the fragments found in an activity can see and access data inside of a view model. Here is an illustration of our view model's ability to persist. So once instantiated, say in an activity's onCreate function, the view model persists throughout multiple activity restarts. So a rotation can occur as an example, or some other configuration change, and the view model will persist until the activity is destroyed with a call to finish or the user exiting the activity. It's important to note that whenever an instance of a view model is scoped against a component, all components that attempt to retrieve that view model instance and scope it against the same component will receive a reference to the same instance. That is, if we were to, for example, scope a view model against an activity, activity A, then any fragment that scopes their view model instance against activity A will all be seeing the same view model instance, which is what allows them to share data with each other because they're all looking at the same object. So let's create a view model, and then we will look at how our components can access and use that view model. So we'll start by creating a new class, and we will call this class Image View Model. To make this a view model, we need only extend the view model class. Once we've done that, this is now a view model object, and we can store any type of data, any type of object, anything we would like inside this view model, and it can be accessed by any component that instantiates it. So before we come back and fill out this view model, let's understand exactly how components can use it. So let's start with our image list fragment. Our goal, if you recall, is to have the selection of an item in our image list fragment be reflected in the image display fragment. So what we're going to do is have any selection that takes place in our image list item be stored in a view model. In order to do that, we must first access an instance of our view model. So we're going to start by creating an instance at least a variable, to store our view model. So I'm going to create an image view model property, and I'm going to initialize this view model inside of my fragments on create. The reason I'm doing it here is that in order to instantiate a view model, I have to specify what component is going to be scoped against. In this case, I want to scope this view model against the activity to which the fragment is attached, which means I need to reference the activity, which means I can only instantiate my view model in a location where I know that I am, in fact, attached to my activity. So it has to be somewhere in my fragment's lifecycle where we are guaranteed to be attached to a fragment. To do the initialization, I'll simply say image view model is equal to, and I'm going to create an instance of view model provider. View model provider is where you specify the owner. In this case, require activity is going to fetch an instance of the activity to which this fragment is currently connected. This is why you must make sure that you are in fact attached to the activity when you execute this code. Once I've done this, I can now, using index notation, specify which view model I want to instantiate against this scope. You do that by providing the class reference, which for us is image view model : class.java. This gives me a view model, image view model, scoped against the activity. This is very different from, say, passing in a reference to the fragment, which is a valid owner. However, if I did this, only this fragment and any child fragments of this fragment would be able to access the same instance of the view model. It would not be one that another fragment in the activity would be able to access. So we also want to make sure that we scope against the correct owner to ensure that every component that needs to access the same instance can in fact do so. So this is how I access the view model. Now, the question is, what do I store in the view model? As mentioned, I can store anything inside the view model, which means what I could essentially have, let's say, the information for the selected item, the resource ID, be stored in an integer. The problem with that is, if I update the view model, how would this image display fragment know that the value has been updated? There is no direct channel of communication between these two fragments. So when the image list fragment updates data, the image display fragment doesn't necessarily know that that change has occurred. In order to address that, we're not going to store our information in just plain integer variables. Rather, we're going to store our information in what's called a LiveData object. A LiveData is an observable data holder, meaning it can be monitored by other components. And whenever a state change occurs in the LiveData, the observers can be notified and react to it or respond to it. So a LiveData is a lifecycle aware observable data object, which essentially means, in the context of Android, a LiveData object knows when it should inform an observer and when it shouldn't. This is especially useful in the case of fragments because we're already aware of the issues relating to timing when fragments are added and removed. By using observables, we can allow all facets of our application to remain in sync with the application state. Essentially, whenever one bit of data is changed by some component, we can have other components respond to that change without having to write a lot of manual code or having to write code that polls or checks for these updates. When we combine LiveData and ViewModels, what we have is a very, very powerful component that is able to live or persist through activity restarts and then inform the new instance of an activity or inform the fragments found in that activity of the state, allowing them to update themselves immediately. So let's place some live data inside of our view model. So inside of our image view model, we are going to create a value called selected image. Selected image is going to be of type live data, but more specifically, it's going to be a mutable live data. Mutable live data because we will want to be able to change the information, where a live data object itself is an abstract class first and foremost, so we cannot instantiate one. But the idea behind live data is that it cannot be changed. So a mutable live data can be changed, and when we create a live data object, we need to specify the type of data that it is going to store. We do that with a generic reference. So in this case, we're going to store an integer value, and I can invoke the primary constructor. So that's my property. And as with some properties, if we want to respect encapsulation, we need to make them private. We're making this private because we want to control access to this property. We don't want everyone to just reach in and manipulate our live data. So we're going to give explicit setters and getters. The first setter, or the first function, will be a setter called setSelectedImage. SetSelectedImage will accept an integer value. We'll call that image ID. And this function will not return anything. What it will do is that it will set the selected image value property to be the image ID. So this is how we change the value stored inside of mutable live data. We access this value property. So every mutable live data will have this. Whenever we update the value, this is what will inform all the observers, all the components that are looking at the live data, that a change has occurred, allowing them to be updated. The second function will be our getter. So we'll call it getSelectedImage. This will not accept an argument. And what it will return is a live data reference, not a mutable live data. Why we're doing this is that we want to hide the fact, we want to conceal the fact that our live data object is a mutable live data, because we don't want any caller of getSelectedImage to take the returned object and try to manipulate it. If we return a mutable live data, they can easily manipulate it and sidestep any controls that we might have in place. Now, to be clear, when we return a live data, it would be trivial for the caller to simply take the object and cast it as a mutable live data, if it is in fact a mutable live data. But at least then they'd have to know the type, and they would have to purposefully make that cast, which assumes that they know why they're doing it. So all we're trying to do here is prevent accidental updates. But if someone is intent on changing it, then certainly they can go ahead and do that. So our live data, again, is of type int. And then here we will simply return selected image. And we need to import this class. So this is our view model. We can set an ID, and we can retrieve the live data that contains the ID, and you'll see how we use that in a second. So let's go back to our image list fragment. And our goal with image list is to essentially update the view model every time the user clicks one of the items in the recycler view. To do that then, we need only go to our callback function that was passed to the recycler view adapter, where we receive as an argument the drawable resource ID as the it reference. And we can simply say image view model dot set selected image it. This will update the view model with the selected item. Now at this point, we have no discernible change in the behavior of our application because we've only done one side of the equation. We're updating the view model, or more specifically, the live data value inside the view model, but we don't have any other component responding to that change. So that's what we're going to do next. We're going to go to our image display fragment, and we're going to have it respond to the change that occurs inside the view model when an item is selected from the image list fragment. So we're going to start out by doing the same thing we did the last time. We're going to get a reference to the image view model. And we will initialize it in the same way by going to our onCreate and initializing it by getting a view model provider, where we pass a reference to the activity. And then we specify that the view model we want that is scoped against the activity is image view model class Java. So this is the view model. What we're going to do next is we're going to go to our onViewCreated, the place where we set up all the state, the place where we know that our view is in fact inflated and ready to be manipulated. And I'm going to access the live data object inside the view model by calling getSelectedImage. Recall here that I'm not getting the integer value. I'm getting the live data that contains the integer value. Once I've retrieved that value, I can now observe the live data, and any number of components can observe and be notified when the data changes. When you're performing an observe, you need to specify the lifecycle owner. In this case, we'll still use the activity. So because I'm in onViewCreated, I can call require activity. And then I need to pass in a callback function. I can use a lambda here and simply place that outside of the parentheses. This lambda will receive as its argument an it reference, which will be the integer value stored inside the image view model. So this int, which is essentially the image ID, is what will be returned whenever the observer lambda is invoked. So all I need to do here then is call changeImage it, where I invoke the fragment's changeImage function, which is what will accept the image ID. Now, at this point, if I were to select an item from my collection, what I'll find is that I see that selection updated or reflected in the image display fragment, because both of these components are looking at the same view model. My image list fragment is updating the live data object inside the view model, and the image display fragment is observing that live data and being notified when the data changes. Now again, it's very important that you scope against the same component. If I, for example, inside my image display fragment had gotten a view model provider where I passed in my fragment reference, which is itself a viable store owner. If I had passed the fragment reference, then this would mean two instances of image view model would be available. One that the image list fragment is using, which is scoped against the activity, and this one that the image display fragment is using, which is scoped against itself. In that scenario, if I were to select items from the list, I would not see that selection reflected below, because this image display fragment is looking at a different ViewModel instance, which is not being updated. What's more, I will not be able to observe the same ViewModel from the image list fragment, because the image list fragment doesn't and shouldn't know about image display fragment. So I can't scope against it because I have no reference to it. The only thing a fragment knows for sure is that it is connected directly or indirectly to an activity, and that is the only thing it should know. So we want to make sure that we scope against the correct component such that when we are updating a ViewModel instance, we're all seeing the same ViewModel and can respond to it accordingly. At this point, there is one other thing we can do with ViewModels and LiveData to make our application essentially rely on a single source of truth for all its data. Right now, both our image display fragment as well as our image list fragment rely on factory methods, i.e. a call to new instance, to create an instance of either fragment that contains some information at startup. And while it may be considered good fragment design to have this mechanism, we could in fact replace the functionality or the capabilities enabled by this particular feature simply by extending our use of ViewModels. So as an example, let's start with the image display fragment. Right now, our image display fragment will update whenever a new image is selected. Essentially, it observes the selected image live data object inside the ViewModel and will update itself whenever that item changes. As a result of that, it's possible to have our image detail, our image display fragment, update with the latest image or update with a starting image by simply setting the selected image property of our ViewModel prior to or even subsequent to adding the fragment to our activity. So we could do that in our main activity by first getting a reference to the ViewModel. So here we can simply say image ViewModel is going to be a value initialized with a call to ViewModel provider, where we pass in a reference to this activity as the owner, and then we fetch an instance of image ViewModel class.java. This gives us a reference to image ViewModel. Now that we have this, what we could do is, instead of starting our image display fragment with this starting value, we could simply call on our image ViewModel set selected image and pass in the starting value. So our ViewModel starts out with this value. Now we'd have to verify some of our logic to make sure that our fragment doesn't keep getting this starting value every time we do a device rotation or something similar. But this is at least as a starting point for us. From here, we could then essentially do away with this new instance function and make sure that our fragment is no longer dependent on it. So inside of our image display fragment, we could, if we so chose, get rid of our new instance, and in our onCreate, we want to make sure that we are not attempting to maintain any arguments or load information from arguments property when the application reloads. We could even go further and verify that we don't want any saved instance state data if we've determined that essentially we're no longer going to be reliant on any internal data and everything will be referenced from the view model. It is not the case that all pieces of information that we would normally operate on within a fragment or even an activity for that matter needs to be exported to view models. These two things can actually work in tandem. So it really comes down to what your overall design says. And we can do away with our implementation of unsafe instance state as well to keep things simple. So at this point, everything about this fragments display is going to be controlled by our view model. And we can even do away with this. So this is a much simpler version. We don't need any of these keys. And now when our application runs, we will have a starting image, which is just what we specify, but this is coming from the view model. Similarly, we could redesign our image list fragment to use a view model to retrieve the collection of data that is provided by the activity. So in order to do that, we'd have to go to our view model class, and we would add a new mutable live data property. So in this case, we're going to have images be a mutable live data of type int array. And then we can just have a setter and getter that follows the model we initially used for selected image. So fun get images. Oh, let's just do our set images first. Now, what's important here is that our data that we're storing is a collection. And it might be tempting to think that when we place a collection or an object that is a collection inside a mutable live data, that if we change elements in the collection, that would trigger the observables. It's important that we realize that that actually does not happen. Observers are only notified if the entire object that is referenced by the mutable live data or that is stored inside the mutable live data changes. In other words, we would have to replace this entire int array that we're about to store with a new int array if we wanted observers to be notified. Otherwise, changing elements inside the collection, if this were, say, changing values at particular indexes or indices, or changing, if this were an array list or something like that, adding elements or removing elements, would actually not notify observers. So you need to keep that in mind if you are, in fact, placing collections inside of live data objects in view models. So here we have two values with the same name. So we want to shadow the properties, and we're setting the value of the, so even though they're both called images, the value of the mutable live data is being updated with the int array. So it's perfectly fine to rename one of these in case you want to reduce the likelihood of ambiguity. So that's perfectly fine. And then we'll have a getter, which will return a live data int array. And here we'll just return images. So now that we've done this, we need to do a couple of things. First, we're going to go to our image list fragment and we're going to change its behavior. And what we're going to do is get rid of pretty much every reference to that would manage our access arguments. So we're simply going to get rid of pretty much all of this. We still need to initialize our view model as we were doing before. And we're going to get rid of our factory method. Now, what we're going to do is when our view is created, instead of simply attempting to say add an adapter, what we're going to do is just the simplest version of this would be to take my image view model and get the set of images. On that, I'm going to observe using the activity as the lifecycle owner. And whenever there is an update, that is when I want to assign an adapter where I pass in the collection that was just given to me. And here they'd like me to shadow, although that's now a little redundant, but you can't have it both ways. All right, so we have a lot of its. So the goal here is I take the live data inside the view model and I observe it. Whenever it's updated, it, in this case, will be the int array. I create an adapter where I pass in the int array, and that becomes the adapter for my recycler view. Now, there are other ways I could do this, nicer ways, objectively, that I could do this. This is just the quick and dirty method. A far nicer approach would be to either move elements from one collection to the original collection. Essentially, this would require that both collections be the same size, or at least I have some sort of dynamic collection, such as an array list. Or, with a little more work, I could have my recycler view directly reference the view model for its adapter. Meaning, the data source that it uses is a collection inside the view model. So there are different ways that we could do this, but again, this is the most straightforward just in terms of getting something functioning. So once I've changed the behavior of my fragment, I can now go to my main activity, and instead of calling the factory method as I was doing before with my set of images, I'll simply create an instance of the fragment, just as I was doing in the previous example, and I'll call image view model set images desert images. And this looks a little nicer if we keep it all organized. So I update my view model with the collection, and I update it with the single element that should start. That should be the default element for my image display fragment. I then create my two fragments and attach them. When I do this, at the time the fragments attach and they start to observe the live data, at that point, the live data will inform the fragments of the current state. So even though the values are set before the fragments are attached, they're still notified of the state of the live data elements, and therefore the fragments can update accordingly. So here you see the exact same behavior, even though the data was set before the fragments were even ready. And of course, it really doesn't matter. I could do this in reverse, and I would have the exact same behavior. I mean, we're not going to really see much of a difference because, of course, this commit is asynchronous. But even if I had put this in some separate event, such as a button click, I would then see at that point the fragments essentially being initialized, quote unquote, with the data found inside the live data element embedded in the view model. So this refactoring of our application essentially allows us to use ViewModel to maintain the entire state of our application, including the collection that our recycler view uses and the default value that our image display fragment will display on startup.